There is a color that for thousands of years was a symbol of royalty and divine beauty. It's a blue so deep and so stable that it has survived millennia, found in the intricate patterns of Chinese porcelain and the stained glass windows of grand cathedrals. And it all comes from an element that has enchanted humanity for most of our history. But that very same element was also used to conceive of a terrifying weapon, the world's first Doomsday device. How could something so treasured by artists and kings also hold the power to end all human life? This is how the world's most beautiful color became a Doomsday weapon. This is the story of Cobalt. Hello and welcome to Meet the Elements, the series where I look at the stories of humanity through the lens of the periodic table. Today we're taking a look at Cobalt, the element that can create a color that's bluer than blue while also hiding the potential to eradicate humanity. Our story begins deep in the mountains of 16th century Germany. Miners hunting for silver would find a shimmering ore. It looked promising, but when they tried to smelt it down, everything went wrong. Instead of silver, the furnaces just coughed up toxic arsenic-laden fumes. The ore was worthless, and the fumes produced from trying to smelt it were too dangerous for it to be worth it anyway. The miners believed the rocks were bewitched. They blamed mischievous underground spirits, goblins, for cursing their silver. The German word for goblin is Cobalt, so that's what they called this cursed ore, and where the name Cobalt comes from. But long before these German miners gave it a bad name, ancient civilizations were already trying to master the color blue, and it was surprisingly difficult. In the natural world, true blue color is surprisingly rare. Pigments from plants would just fade away over time. The most famous source was the semi-precious stone lapis lazuli, but it was reasonably expensive and difficult to turn into a paint. Ancient Egyptians were able to find a workaround of sorts. They created a pigment we now call Egyptian blue. It wasn't made from cobalt, but from a mixture of copper, sand, and alkali. For a long time, this was the blue of the ancient world. But as early as the Bronze Age, artisans figured out that adding a tiny pinch of cobalt-containing minerals to molten glass created a stunning deep blue that was ridiculously stable. This cobalt glass was named smalt and could be ground into a versatile pigment that could be used in pottery, jewelry, and eventually stained glass. This smalt made its way to China and exploded. During the Tang, Yuan, and Ming dynasties, cobalt glass became the star of their iconic blue and white porcelain. The magic of cobalt pigments was their incredible stability. It could survive the heat of the kiln and come out looking bluer than ever. The turn of the 20th century was a time of mind-bending discovery. Scientists were doing more than simple observation. They were taking apart reality and learning its fundamental rules. Part of that was figuring out that elements had different types. We call them isotopes. For those not sure what that means, let me explain. An element's identity comes from its number of protons. Every single atom of cobalt has 27 protons. That's non-negotiable. If it had more or less, then it wouldn't be cobalt. But the number of neutrons can change. Atoms with differing numbers of neutrons are called isotopes. Chemically the same, but nuclearly different. And we refer to different isotopes by their mass number, the number of protons and neutrons added together. Now, all naturally occurring cobalt on Earth is the stable, well-behaved cobalt-59. It's predictable. Safe. But cobalt-59 has a cousin, and this one is volatile. It's cobalt-60. It has the same 27 protons, but one more neutron than cobalt-59. And that one extra neutron makes its nucleus unstable. And an unstable nucleus will eventually do what all unstable things do. It will fall apart. For nuclear decay, this involves violently spitting out energy and particles. What makes cobalt-60 so uniquely dangerous are the high-energy gamma rays it releases. Other types of radiation can be stopped by a piece of paper or even your skin, depending on the type. But gamma rays will pass right through you, shredding your DNA and causing havoc inside your cells as they do. As the Cold War draped its paranoid shadow over the world, military strategists sought out bigger and better atomic weapons. Amidst all of this, one of the scientists who worked on the Manhattan Project, Leo Szilard, calculated that a tenth of an ounce of cobalt-60 sprinkled on every square mile of Earth would create enough gamma radiation to kill the human race. Szilard also conceived of a new type of nuclear bomb, one that was meant to do more than kill. It was a weapon that would poison the land itself and make it uninhabitable. This was the dirty bomb. You might think any nuclear bomb would produce a mushroom cloud, but not a dirty bomb. A dirty bomb is much, much worse. It will rain down radioactive shrapnel over an area and make it impossible for human life to live there. It starts by encasing a nuclear device in a jacket made of cobalt-59. A fission reaction sets off a fusion reaction and blows apart the cobalt jacket. but not before the cobalt changes on an atomic level. The barrage of neutrons from the fission and fusion reactions change the cobalt-59 into cobalt-60. As the jacket explodes, radioactive shrapnel rains down and embeds itself in the soil, rendering the area useless to humanity. With cobalt-60's 5-ish year half-life, the contaminated zone would be deadly for a long time, at least the length of a human lifespan. Any cleanup is slow, dangerous, and expensive. It would turn a city into a ghost town with an invisible poison. Sillard never wanted this to be built. It was a thought experiment to show the illogical and insane endpoint of the arms race. It was the ultimate threat, a weapon you would build so you never have to use it. Thankfully, as far as anyone knows, a full-scale Cobalt-60 bomb has never been built. The idea remains a warning of the dangers of nuclear war. Our journey from a beautiful blue pigment to the blueprint for Armageddon is now complete. So the story of Cobalt is really about how a single substance can hold both breathtaking beauty and unimaginable terror. But even that terror can inspire. The idea of a cobalt bomb directly inspired the Doomsday machine in Stanley Kubrick's Dr. Strangelove. For thousands of years, we used cobalt to capture the color of the sky and sea. It was given its name by German miners who thought the rocks they found were cursed by goblins. And it ended up as a warning against nuclear weapons. Cobalt's story is a sharp reminder that the power to create and the power to destroy can often come from the same place. The difference isn't in the element, it's in us. It's the choices we make. The artist's brush or the military's doomsday plan. They all start with the same element. What we decide to do with it is what defines us. Thanks for watching. For me, I will always associate cobalt with the color blue. The kind of blue that is resilient and strong. But tell me what you think. Were you surprised that cobalt has the potential to make the planet unlivable? Let me know down in the comments. And don't forget to leave your suggestions for other elements you think should have their story told. And if you want more videos about the elements that captivate humanity, make sure to subscribe so you don't miss the next episode of Meet the Elements.